Well, I had a few people ask. I thought I was done with these Browning 180 amps, but I had a few people ask what do I think about repairing them, or what problems have I found with them. So I'm gonna do I guess fairly short for me video on that. These are two Browning 180 amps. Both match the Mark III, and actually, except for the Browning DC, I think 170 amps, the Browning amps like these, the 100, and they got a 180 that matches the Mark 1 or 2 radios, and this 180 that matches the Mark III radios. Actually, this one got Mark III on it. Except for cosmetics, meaning looks, they're basically the same amp. They just changed the looks or style to match the radio that they were selling at the time. So anyway, back to fixing these before I get too long-winded. The number one problem I found with these amps is the transformer is blown. That's a little transformer original in this one, and these little 2-tube amps, they do 50 watts, with a 4-watt radio is what they do. But for one thing, people try to push them too hard. Everybody wants more watts, so they push it harder, and they'll kill the tubes eventually, but tubes can be easily replaced. They're not cheap nowadays, but you can replace the tubes. But eventually you push it hard, or don't change the caps or the diodes, which I'll get into in a minute. It's gonna pop the transformer, and once that goes, I'll show you what I do when I turn it over in a minute, what I did on this one. There's a toroid transformer underneath. There is what I replaced that transformer with, because I can't find anything original that fit in there, and I buy a toroid, which gets more power in a compact, or less space, higher efficiency. So I'd replace the transformer with a toroid when they go. This tube here again is a keying tube. It's not a driver tube. It has nothing to do with power. All it does is when it senses the radio coming in, it keys the relay over here. And this is the original relay in these guys. The cap on top of it is not. Well, actually, it's the original cap, but I moved it because I didn't have room because of the toroid under there. But the cap is just delay for SSB is all it is. A little bit of delay on the cap there. But sometimes the relay sometimes the relay's dirty, and all it needs is cleaning the contacts or burnishing the contacts. This one, the relay was completely gone, and the relay was replaced. Now, mind you, since this relay is keyed by the tube, it's a high voltage relay. This relay takes 120 volts to key it. So what happens is when you key your mic and the radio senses or the keying tube there senses the power, it kind of puts a semi-ground on the ground side of the relay, and that's what keys the relay. That relay is connected to the center tap of the high voltage. So again, if you need to replace it, that's 120 volt DC, and if you notice, it's just a 2-pin or 2-pole relay. All it has is in and out. RF in on one pole and RF out on the other. There's no contacts for switching to turn the transformer or bias for the grids or the tubes or anything like that. So one design that I don't like about this amp, I wouldn't call it a flaw, but it's awful close to it, that when you turn this amp on standby, the transformer is not engaged. But when you turn this amp on, all the high voltage and everything else is going to the tubes. So the tubes and the transformer and the power supply are sucking power and heating up and all that, even if you're not keyed down, because again, there's no pole or switch or contact on the relay to cut, you know, the power off when you're not keyed down. So if you're going to use this amp for a continuous time, leave it on standby. When you're ready to key down and all that, put it on, and then when you're done with your QSO, turn it back on standby or off. Again, I think that's one of the reasons that the transformers go in these guys so much, is people, you know, leave it on because they're like, I'm not keyed down, you know, and this amp has no fan or cooling in it either. So you leave it on, you know, for extended amounts of times, them tubes is going to heat up. They got power on them, and the transformer power supply is going to heat up. And one thing that'll kill an amp is heat. So I'm going to turn them over now. And since this is supposed to be a repair, I'm going to go through the problems again. And that's the bottom side of the original transformer. Number one problem I see people, you know, leave them on or run too much power and they kill the transformer. This is the heavy duty toroid, and the other one that had a bad transformer that I replaced. I guess the number 2 and 3 problems I see with these are also the high voltage power supply. These are replaced high voltage capacitors in them. They, you know, 50, 60-year-old amp, they dry up the capacitors. You know, capacitors aren't made to last nowhere near that long. So the capacitors dry up. Sometimes they short out, and when they short, they take out the transformer. So replace the caps. And if you notice that these are 600 volt caps, and over in this one with the toroid, they're 500 volt caps. Now most electrolytic caps, high voltage, are 450, and to get to 500 or to 600, it costs a bit more. But these amps run about 800 volts back in the day, when, you know, your line voltage was 110, and nowadays the line voltage is about 120, and these amps are run about 850, 875 volts. And each of these caps, since there are 2 of them in series, you know, their rated capacity, if they were 450 volts, and 2 of them would be 900 volts. But again, if the amps run it at 850, 875, you're close to the, you know, peak tolerance of those caps. And even from the factory, in the schematic, let's see if I got one here. Yep, this is a printout of the schematic from CB Tricks, and you can see that C2 and C3, the original schematic, those caps were rated at 500 volts. And you can see here that it's got 800 volts when you key down and 1000 in standby. So don't replace these caps with your standard 450 volt caps. At least get 500 volt caps when you replace them, and you do need to replace them. One other thing that goes in here is that block there is a bridge diode. It's just 4 diodes in a full wave bridge configuration is all that is. You can replace that with 4 or 8 diodes if you want to for the voltage again. But that bridge also goes, the diodes, or one or a few of them in it, go and it is short. And once that's short, oftentimes it'll take out the transformer. So that's one thing to check for, is check the bridge for the 4 diodes. You know, diode tests on the meter and make sure none of them are shorted, and that your bridge is good. If not, replace it. And most people, like again, commonly replace it with just 4 diodes in a bridge configuration. But that's the main things that go in these amps, is again the transformer first, and the transformer that went in this one and it was replaced. The caps go, and I recommend replacing them before they go and before they take out the transformer. And number 3, that bridge diode. Actually, again, because this toroid took up so much space and I moved it to underneath because there wasn't any room on top, this one has the original bridge under that cap. It's in there. It's just moved and hidden a little bit. But I have seen the little rotary power switch on the front go, but not too often. And your tubes can go, but you know, tubes can be replaced. Speaking of tubes, this amp runs originally two 6JG6s, but if you look at this little chart here, 6JG6, 6JR6, 6JT6 are pretty much all equivalent, and the heavy duty version of it would be the 6kV6. Since 6kV6 are a little bit heavier than the rest, of course they're more expensive when you try to find one. But I guess if you want the best peak performance out of this amp, get you a good set of 6kV6 tubes. And if you push this amp hard, I recommend no more than a 5-watt drive or less. And this amp is good for maybe 50 watts. You know, if you did 75 peak out of it, you're doing good. Just a little 50-watt amplifier or driver. And only thing I really like about it is because it's browning. That tuner there, again, if you haven't seen my other videos, is the input tuner. And I guess it's safe. I'm going to turn it on, and hopefully everything's hooked up and still ready to go, and I haven't turned nothing. And we're just going to key it down right quick at the end of this video. But if you get one, change the caps, check the diodes before you do anything. And once you do that, I suggest you get a variac if you don't have one, or you do a lot of testing and getting vintage equipment like this, and put it on a variac and slowly turn it up. And my variac there has a amp meter, and with this thing at full voltage, it only pulls about 1 amp. I don't have it on the variac right now. And I also got that volt and amp meter in line so I can see what this thing's pulling. And basically, if it starts pulling a lot of amps, when you either plug it in or use the variac, I bet your tranny's gone. If not the diodes and the tranny. But if it starts pulling amps or blowing fuses, check your transformer. It's probably blown. So anyway, hopefully this thing's warmed up. And gotta key it down. Now mind you, this is the hot one with the toroid, and I must be on peak already. Audio, audio. Hello, 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 hello. I'm getting about 90 watts peak. Hello, hello, hello. Talking about 45 average. Whistling to about 60. Hello. Hello, hello, hello. See, the relay is a little bit of a delay. I don't know if that's a good picture. Don't want to get too close with that high voltage on in there. Well, maybe from that angle. But there's just a touch of delay keying it up and unkeying it. And that's just the delay cap on top of it. On this original one with the transformer, that cap there is where the delay cap normally is. But again, since this one got the toroid, I just moved the circuitry in it to fit the toroid underneath. And last, I just wanted to show the input SWR. 1.7 on that one. That's about lowest I can go. But that's all the tricks to this amp. I know I'm just being redundant and repeating myself, but transformers go, replace your caps, check your diodes. Sometimes the tubes go. But usually if the tubes go, it won't kill the amp. It's just you got low output. And that's about all I can think of with this video on top of my head. So that's going to be it for what I think of repair problems with the Browning 180 amplifiers. Bye.